Hello, everyone. If you can see us, say hello in the chat on YouTube. We are going to get started in just a minute, but we like to wait a little bit because we don't know how quickly we actually go live. So say hello. Let us know that you can see us. Is that, oops.
Oh, people are saying hi in the chat.
Hey, Jamie, do you have the YouTube video open on your computer?
I don't, but I can check.
I can hear myself, which is...
I don't have it open on my computer.
Sorry, guys, technical difficulties. Where am I hearing this from? Can you hear it, Jamie?
I cannot. I like sort of hear it in the background of your Also, someone
in the chat, can anybody let me know if you can like hear me in double, basically? Oh, I think I got it. Now it stopped. Whew. All right. Sorry for the technical difficulties, everyone. I hope everyone is having a nice Tuesday. It just started snowing here. I was just telling Jamie. So hopefully we stay online the whole time and no more technical difficulties. This is the third week of the Stats live stream series. Oh, everyone is saying everything was fine. I think it was something wrong with my audio. My audio and these things are, I've had a few issues, so I'm glad that everything is fine for everyone else. So this is our third week of the Stats live stream series. I'm Sophie, if you haven't attended yet, and I'm here this week with my colleague Jamie. So Jamie, do you want to say hello to everyone and introduce yourself quickly?
Hi, everyone. I'm Jamie. I'm also a curriculum developer at Codecademy with Sophie. This is the first live stream I'm doing for the Stats live streams that Sophie set up. I'm really excited to be here. You may have seen me on a couple past live streams with some things we did before. Yeah, and I'll be answering some questions in the chat and monitoring it as Sophie leads us through associations with variables.
Yeah. Awesome. So yeah, with that in mind, I think we're streaming on a few different platforms, but we are keeping an eye primarily on the YouTube chat. So if you're on Facebook or Twitch or any of the other platforms we're on, come on over to YouTube if you'd like to chat along with us. And just as a reminder, these are always posted after the fact, so you can always watch them afterwards, and you can post questions in the comments on the YouTube video. We're happy to answer more questions if you're not able to come to the live sessions. So with that said, I am going to get us started. If you've been following along, we have been working off of some code that is available on GitHub for download. I know, Jamie, if you're able, could you maybe post the link to that GitHub in the chat? And I think it should be in the YouTube link as well. And in the meantime, I am going to share my screen. Share. Hopefully you guys can all see that. Jamie, can you see my screen? Okay.
Yes, I see it.
Awesome. Okay. So if you downloaded the code from GitHub, we are currently in the week 3 folder. So that will be Codecademy Live Stats number 3. And I'm going to start with this starting code file. But you can also take a look at the final code. It might not be exactly identical to what we get to in this live stream, but it should give you an idea of the kinds of things that are covered here. So with that said, I'm just going to get started because we always run out of time in these live streams. Somehow we have lots to say. So with that said, today's focus, like Jamie said, is really about looking at associations between variables. And really what that means is we're looking at in a data set, again, this is the same data set that we used last week, but I'll just show everyone this data set again. So this is a data set from StreetEasy that has some information about apartments in New York City. And if we're asking about associations between variables, we're asking about the relationships between these different columns. So things like rent, the number of bedrooms, the number of bathrooms, the size in square feet, and a whole bunch of other things that we know about each of the apartments in this data. So Jamie, can you think of a question that might focus on an association between two variables? Like what question might we ask that has something to do with whether or not two variables are associated?
Well, I actually feel like this is very relevant to me because I will soon, hopefully, be looking for apartments in New York. And the thing I will care about most is price of those apartments. So I might think about, how does the amount of bedrooms or how does the square footage or the minutes of subway associate with the price of said apartment in New York? So that might be something I personally might look at, but there are a lot of different associations you can look at between these variables.
Yeah, I think that's a perfect point. So I think probably what many of us are drawn to about this data set, I know it was the thing that drew me to this data set, is trying to figure out, based off of this information that we have about apartments in New York City, can we kind of predict or guess what a fair rent would be for a particular apartment that has certain qualities? So that's a particular size, that has a particular number of bedrooms and bathrooms, that has certain amenities or does not have those amenities. And all of the questions that we might ask about how rent is related to other things that could be true about an apartment. Those are all questions about associations between variables. One thing that I would like to kind of point out is that an association is different from a causal relationship. And I think a lot of us have kind of heard this before. Like a lot of people have heard the saying correlation is not causation. And I think I have also seen, I don't know if you've seen this, Jamie, like the Spurious Correlations blog.
I love
that. We can, if you're interested, you should definitely take a look at Spurious Correlations of things that are clear, that seem to be clearly related to each other, but there's no way that one thing could cause the other. And so, like, for example, if we find that there's a relationship between the square footage of an apartment and the rent, so like you might guess, right, bigger apartments can go for more money. That doesn't necessarily mean that if we added more square footage to an existing apartment, that then people would pay more. We might think that that's true, but this data is not going to tell us anything about that, because in this data, we only have, each row is an apartment, and we don't have any data about what happens to apartments if we change them. So we don't have a bunch of data for the same apartment at different time points when it was made bigger, like it had an addition, another wall was put up to add another bedroom, nothing like that. So we can't really say anything about what happens with changes. But, oh, thank you for sending the Spurious Correlations link. That's great. Yeah. But with that said, it's still really important. For example, for Jamie, if he wants to go out and find an apartment in New York City and he's looking at different apartments and he's, I want 2 bedrooms, but I really want to have a roof deck or some outdoor space. And so like, maybe I'm willing to go down to 1 bedroom and so one of my roommates will sleep on the sofa and just to have that outdoor space, especially in the time of COVID. So if Jamie wants to answer kind of the question, what is a fair rental price, or what do apartments like this go for, or what can I afford given these things that I want to definitely have, then he's really going to be interested in trying to understand some of these relationships. Okay, enough rambling from me. I did see some questions in the chat about people wanting to learn how to code and like set up a Python project. And I would really encourage you, if you're one of those people, to take a look at the first live stream series in this, or the first live stream in this series, because we kind of go through the full all the steps of setting up your local environment. And there's information in the blog on how to download Anaconda to make things really easy. And I think that will really help. And now we'll get into the coding. The other thing is I put this kind of data cleaning step in from before. This is not something that I would normally do to a data set. Jamie made a good point about this. I wouldn't normally just like change all ones and zeros to yeses and nos. But it does make it a lot easier to make some of these visualizations and do some of the analyses that we'd like to do. So with that said, okay, so let's get started. I think I like to break down thinking about associations between variables into the types of into sets based on the types of variables that you're trying to look at an association between. So in this data set, we have some quantitative variables. So the quantitative variables here are kind of the things that can be numerically represented, like rent, the number of bedrooms, the number of bathrooms, the square feet, minutes to subway, and floor. I would say that all of those are quantitative variables. And building age and years. All of these, all the ones that start with has and then the no fee column, as well as neighborhood, submarket, and borough, those ones are all categorical. So you can represent them with numbers, like these are ones and zeros, but it's really about a category, right? Like either there's a gym or there's no gym. And so we're going to break this down into the types of variables that you're looking at an association between. So we'll start, it doesn't matter which one we start with, but we'll start with one quantitative variable and one categorical variable, just for fun. So we're going to stick with rent, I guess, for the quantitative variable to start, because I think that's an interesting one. And then we can look at a couple of different categorical variables to that end. Okay, so last week we started talking about the central tendency of a quantitative variable, and we talked about mean and median and mode. So I'm going to start with a summary statistic that's a lot like that, but now we're going to kind of combine two variables at once. So in our data set, I've named our data rentals, and then the rent variable is rent. And one thing we can do is we can calculate, let's say we're interested in an association between rent and borough. We then could calculate that at least some sort of central tendency statistic for the rent in each borough. And that would give us a sense whether there are differences by borough. So is the average rent, for example, higher in Manhattan than it is in Brooklyn? So one thing I like to do is you can calculate this kind of separately. You could pull out one column at a time, filter, and then calculate the mean. And that's how we teach it, I think, in the Codecademy lessons, just because it's a little bit simpler to see the full process. But in this live stream, we're going to go one step further and try something new because it's fun. And we're going to try a group by. Basically, all that does is it says, I want to calculate some statistic for particular groups within my data. And so I'm going to group by borough here. And actually, and then I'm going to calculate the mean of, and eventually I want to calculate the mean of rent. But I just want to show you what this does right off the bat. So if I just say group by borough and calculate the mean, it's going to pull out all the quantitative variables separate them by borough, and it's going to calculate the mean for each one. So this is kind of a nice way to quickly kind of pull out these summary statistics by borough really, really easily. And then we can also specify. So if we want to then pull out just the rent variable, we can add that to the end here. And then now we've just got mean rental prices for each of the boroughs. Another thing we could do is calculate median rental prices for each of the boroughs. So I'll do that as well. And then we'll take a look at these. So Jamie, what can we take away, do you think, from, or what can we learn from these summaries? Or do you have any thoughts about them?
So one thing I'm noticing, well, first of all, Manhattan is expensive. That's
Yes.
the first thing I'm noticing. Another thing I'm noticing is that if we look at the mean rent prices versus the median rent prices, there is something I'm noticing across each borough. And that is that the mean, I think in every borough, every borough, the mean in every borough is greater than the median. And I believe that would show us that the rent prices is skewed right.
Yeah, exactly. We actually looked, I think, last week at a histogram of the rental prices, and we'll do that again in a minute, but that's exactly true. So I think there's a couple different visualizations we can use to take a look at this in more context. So Jamie made a really good point that taking a look at these can give us some hints, but sometimes it's really hard to look at numbers, visually compare. Like, I know, as Jamie was saying, that's true in all of them, right? He was kind of going through like checking them one by one. And that is a lot faster to do when you have a visualization. Yeah. So let's make a visualization. There's a couple that I think are good for this kind of an association. I'm going to start with a box plot because that's maybe the simplest of all. And then I'm going to plot, so I'm going to plot rent by borough. And let me just make sure. Okay, so on my x-axis, I want to have the borough that an apartment is in. On my y-axis, I want to have the rent of that apartment. And my data is called rentals. I think that is all I need. Let's see. There we go. That looks interesting. Okay, so this tells us a little bit. We see, just like Jamie said, right, that these are pretty skewed. So these outliers, these diamond shapes are outliers in the box plot. And we can see that in Manhattan and Brooklyn especially, we've got apartments that are renting for up to $20,000 a month, which is crazy. And so when we calculate the mean, all of those really large numbers are getting added into the numerator that we use to calculate the mean. When we calculate the median, it doesn't matter whether this is 20,000 or 10,000 or 7,500. It counts just as much because it's, as long as it's on the high end, it's not going to be the median, or it's going to contribute to, I like to think of it as like crossing off the large and small values. It's going to get crossed off no matter what. And so a lot of times you see exactly this, that the median is smaller than the mean if there are a lot of large outliers. So we do get a sense of this. This picture is basically telling me that the median and the boxes, again, they cover the middle 50% of the data. So the middle 50% of Manhattan apartments seem to be roughly between like $3,000 a month and $6,000 6,000-ish.
About 6,000, I'd say.
And then we're looking at Queens. Queens is much more squished. This middle 50% is kind of squished around 2,500, it looks like. And then Brooklyn is also much more squished than Manhattan, it looks like, and a little higher than Queens, but not considerably higher, but with a long tail of outliers over here. So we've learned some things from this. I think that this graph is a little hard to look at for me because these outliers are kind of squishing the boxes where I can't really see the boxes themselves super well. So this is not so much a focus of today, but I think it's useful to see how like you might alter some of these data visualizations to get a better sense of things. And so what I'm going to do right now is I'm actually going to just filter my rentals data for rentals that have a rent that's, let's say, less than, what do you think, Jamie?
I guess we can do like less than like 12,000 or 10,000 or so.
Yeah, I was thinking 12.
Yeah. Then it basically cuts off most of the outliers for Manhattan.
Let's try that. I'm just curious. Whoop.
I think you did 1,200.
Oh, I did. Oh my God. That's what I would like to pay. Yes, 12,000. That's a lot easier for me to see. And generally when I'm looking at this, I'm looking to see how much these boxes overlap. And the fact that these boxes don't overlap very much at all is kind of an indication to me that these are pretty highly associated variables. There seems to be a clear indication that, or it's clear to me that if I know what borough an apartment is in, it gives me some information about what the rent is more or less likely to be. So that's useful. I think maybe it's fun to try a couple more of these with different categorical variables. What do you think, Jamie? Is there any that you're interested in? Like, what would you like in your apartment?
What do I like in my apartment? Oh, so many things. All these things where it's like I just like want them to have them, but you know.
I know. I feel like for me, the washer dryer is, I mean, it's hard to find in New York City, but.
Does that mean like it has like a washer dryer built into like it's like in your apartment, like, or like it's in the apartment building? You know what I mean? Like,
I don't know. Actually. That's a good question. At least one or the other is pretty important to me. Yeah. As I don't like going to a laundromat, but you know,
let's try.
Sometimes you have to.
Dryer.
Okay.
Yeah.
Let's see.
Someone is asking also, so someone asking in the chat, what's the thing you Googled last time? I don't know if it was from like a previous live stream.
I think we definitely did some Googling of functions. We looked at some function documentation. I think we looked at the function documentation for a trimmed mean, like the trim mean function. Yeah, we can definitely demo some documentation, like function documentation again, because I think it's really useful to take a look at as you're trying to navigate Python. Or any coding language for that matter, but especially if you're interested in data analysis, you're using Python, and you know that requires loading a lot of different libraries. Then it can be really useful to know how to like look up the different libraries, look up the functions that exist, and read that documentation. Interesting. So these are closer than I would have guessed, Jamie, but they are. It definitely seems like if it has a washer dryer, the rent is going to be higher. Unfortunately, I'm sorry.
Sad.
But not by too much. You can definitely, there's some overlap here. These are all expensive apartments, but
it doesn't look like the median is that different. That's the thing that's surprising me. Like
the scale is so hard though, because like the scale goes all the way up to 20,000. So like this much difference could be like
500 or 1,000? I don't know.
Here, we can do,
You can trim it.
we can do like median and do with has washer, dryer, and see what it actually is.
Okay, it's
like
about
600. Yeah, $600 difference.
Also,
Not too bad.
We have another interesting question. Is it possible to take a look at the rent for apartments with all those features, washer, dryer, gym, etc.?
Yeah, so I think there's actually like two good questions in that. One is, so you could create like a new dummy variable. So you could say, okay, I want to create a new variable that is equal to 1 or yes if all of these things are equal to 1 or yes, and then 0 otherwise. There's a few different ways to do that. Maybe this is a good, I'm trying to think if like this is a good use of our time to look up some function documentation, or if it's going to take us a while, but essentially, right, like you could create a new variable based off of some combination of existing variables to say like, if all of these things are 1s, this new variable is going to be a 1. If any of these variables are not a 1, then this is going to be a 0. And then you could split based on a new variable that says like whether all of those things are true or at least one of them is false. You could certainly do that. If you're interested in kind of the relationships between all of these different variables at once, so like, for example, just among apartments that have a elevator, is there a difference between apartments that do and don't have a washer dryer? Or just among apartments that have an elevator and a dishwasher and a doorman, because those are like, maybe those are non-negotiables for you. If you want to like subset your search even further, those would be a hard set of non-negotiables to have, I'm just saying. But if they were, then you could subset your data to just include apartments that met that criteria, and then you could look at this breakdown again and kind of see whether the relationships still exist after you've kind of controlled for these other things. And that's actually what linear regression will do for you as well. Cool.
And then I don't know if it's even possible with this data set, but someone's asking, is the price less for a high floor with no elevator?
Sure, let's see.
I don't know.
We could definitely look at that. So we could say like rentals, high floor, or actually, we'll just do like this. I also see somebody asking about a case when situation or if then logic. Yeah, that sounds right to me. Yeah. I come from an R world where I would do like a mutate function in dplyr if anyone's coming from R, where I would say like, I want to create a new variable based on these other variables and then do that. But you could definitely use like a loop, or I'm sure there's a pandas function. You could technically use the .all function with maybe some pre-processing. Yeah. Yep, I would agree. Yeah, I bet if we have some extra time at the end, I think it would be a cool thing for us to like try to do that live. But I want to make sure we get through some more stuff. So I'm going to leave that towards the end. But I think like these are really great questions. And I think that this is the kind of thing that like is great practice if you have some extra time on your own. If you want to try to like figure them out yourself, just takes a little bit of Googling, and I feel like that's how I learn best, is I just try to answer questions for myself that I'm interested in. And then as you Google more, you pick up more and more syntax. Okay, so we were going to do like rentals.floor greater than, what's a high floor, like 30?
Yeah, I don't know.
Still seems to be a difference. Oh, and actually they were asking about elevator. You could try that too. There's lots of things that you could look at. Oh,
Oh,
those look similar.
yeah,
I guess if you're on a high floor, then you probably live in an apartment that has an elevator. Like, it surprises me that there's so much of a box here. Like, how many apartments are there where the floor is greater than 30 and there's no elevator? That seems well, that seems like another potential data issue that I'm not quite sure how to. Oh, hi, Alex. This is exciting. Okay. So anyway, I think this is a good place to stop with all these visualizations, but I did want to show one more. So we've been looking at side-by-side box plots. Another great visualization for a quantitative and a categorical variable is an overlaid histogram. For the sake of time, I'm going to just grab some code from my answer key. But I do want to talk about one thing. So the histogram function from matplotlib, pyplot, is just a function that creates a histogram. And all I'm doing here is I'm splitting up by borough. So first I'm plotting a histogram of all the apartments in Manhattan, then in Brooklyn, then in Queens, and then I'm labeling them, giving them a number of bins. And then the alpha thing is just making them see-through so that we can see all of them together. One thing I want to demo, though, before we do this is this density equals true piece here. The other thing I'll say is this looks really ugly. There's in the newest version of Seaborn, there's a seaborn.histplot function that exists in the newest version. For some reason, my computer freaked out when I tried to update it this morning. So I did not get it updated in time, but that will make this much easier. It'll make it as simple as this, where you say what you want to divide by. But you'll see that if I print this without the density equals true, this Queens histogram is super, super tiny. And this Manhattan histogram is super, super large. Jamie, do you have any thoughts? I'm putting you on the spot here, but do you have any thoughts about why that's happening?
Okay, so let's see. We're showing rental prices and then it's number. Oh, is it just because there's many more apartments in Manhattan than there are in Queens and Brooklyn?
Yeah, that's exactly right. So by default, the histogram is plotting a frequency. So we talked a little bit about this last time, where each of these bars represents the number of apartments that have a rent in that range. So this first bar, or I don't know, it's hard to read this scale, but this first bar, let's say it's between 2,000 and 2,250, and there's just under 100 apartments that are in that range, according to this. Because in our data set, there's just so many more apartments in Manhattan, this histogram is just going to be bigger no matter what. And there's so many fewer apartments in Queens, this histogram is going to be smaller no matter what. So a way to fix that is to say, I want the density. Or if you've seen a KDE plot, basically what this does is it normalizes this so that the area of each of these things has to be the same. So that technically the area of all of these histograms, the green one, the orange one, and the blue one, now has to be equal to 1. And that just means that now all of these histograms are on the same scale. Now we can kind of look at them and we see this distribution of of apartments in Queens. The apartment prices are squished down at the lower end. And then you see in Brooklyn, it's a little more elongated with a longer tail. Kind of there's more of these mid-range apartments. And then the Manhattan ones, this peak of the blue is happening the furthest to the right with the longest kind of tail out to the right as well. Cool. All right, so we finished one set of variables. Great. Okay, I think now is a good time to move on to a different set. So what do you want to do next, Jamie? Do you want to do 2 quantitative variables, or do you think we should do 2 categorical variables?
So we've been doing categorical variables with quantitative variables. So,
Yeah.
well, with a quantitative variable. I think, I don't know, maybe we could do 2 quantitative variables this time.
Okay, that I'm on board. I feel like this is maybe the other one that's the most intuitive, at least. So
maybe like square footage with rental price.
Yeah,
or something
totally.
Like
yeah. So let's figure
that.
out like
I'm interested in.
Yeah, let's figure out what square footage you can afford, Jamie.
Also, Alex made a comment that the tail on Manhattan is interesting. Lots of super expensive apartments in Manhattan. Yes, I noticed that too, Alex.
Yeah.
Lots of expensive ones.
So many. Let's see. What do we want on the x-axis? I think it's the highest square feet. And then rentals, rent, and LTH. Ooh, there we go. Okay, so I guess last time we started with a summary statistic. This time I'm starting with a visualization. In real life, I will say I almost always start with visualizations before ever calculating summary statistics, because it's just so much easier to just like feel like you understand what's going on if you can just look at a picture. And so this looks, pretty much like I would expect. So we see, I don't know, you could kind of draw a line through this where the apartments that are, and I guess we should add some labels. I forget I think it's like PLT dot X
label.
X
underscore label. I don't remember if it's underscore or not.
Let's just try it.
Oh.
X label.
Oh, maybe it's without the underscore.
We're gonna try. Oh
yeah.
Yeah.
It's without the underscore.
And then we'll try Y label so we can see what's going on. And yeah, so we see like the super small apartments are the least expensive ones. And in general, apartments that tend to be bigger tend to cost more. Although there are some kind of outliers here. Like there's this one where this looks like it's a pretty big apartment, but it's a little less expensive. This one looks like it's a more, is that the apartment you'd like to rent, Jamie?
No, that's the apartment I have lots of questions about, that it's
oh yeah, I guess
so
it's
expensive
smaller.
And it's
yeah, it's very, very expensive, but pretty small. Must be a very nice small apartment. I don't know, probably has a gym and a doorman and an elevator and a patio and whatever other kind of amenities.
Everything.
Yeah.
Washer dryer.
Yeah, exactly. So this is a really helpful picture. I think in terms of summary statistics that can be used to kind of describe this all at once, the most common one is the Pearson correlation or the correlation. There are different kinds of correlations that you can calculate. But I think, so depending on what your data looks like, you might choose different ones. But I think the most common that I've seen is the Pearson correlation, which essentially it gives you a number between -1 and 1 that tells you how strong of a linear relationship there is between 2 variables. And by linear, I mean whether you could draw a line through those 2 variables or not. So, so 2 variables could be related in some other way. Like you could imagine a plot where maybe like as the square feet increases, the rent goes up. And then as it increases even more, it goes down. That obviously isn't the case here. But like if you saw the dots doing some sort of U shape, that would be a non-linear relationship. I would still say that there's a clear association between those 2 variables. There's a clear pattern there. But something like a correlation wouldn't pick up that pattern, or as a statistic, the correlation wouldn't pick up that pattern. But it's still a really useful statistic for understanding at least the linear relationships between two variables. So any set of variables where as one increases, or I don't like to use that word, I should stop, where larger values of one variable are associated with larger variables or smaller variables of the other in kind of this like where you could imagine drawing a line through it. So I think it's useful to calculate the correlation. There's a few different ways you can do it. There's a function from SciPy stats. SciPy stats import Pearson R, and you can calculate like the Pearson correlation of these two, and it should be, yeah, it's pretty high. So 1 would be a perfect correlation, negative, or a perfect positive correlation. -1 would be a perfect negative correlation. So you could draw a line with like a negative slope going down instead of this, which is going up. And 0.8 would be considered like a very strong positive correlation. This number is a p-value, and we're going to get to that later. So you don't have to worry about it. The other way to calculate a correlation, and I think this is kind of fun to explore for a minute, is that you can do the .core function on the entire, or method on the entire data frame. And what that will do is it'll calculate what's called a correlation matrix between, in this case, it knows that this is kind of part of the reason why I made all of the categorical variables yes or no, because now it knows that those are categorical variables, not numerical variables. And so it's got all of my numerical variables in this kind of matrix where it says, okay, the correlation between rent and bedrooms is 0.53. The correlation between rent and bathrooms is 0.73. And so I can see all of my different pairs of variables. And another like useful thing to do, because again, I think numbers are really hard to see and spot like relationships really fast. So I'm going to pull this over and I'll just describe what this code does. So this is a way that we can kind of visualize this matrix of values. This diverging palette thing, basically each of these numbers corresponds to a color. And all I'm doing is I'm creating like a color palette that starts at one color and gradually turns into another color. And then what this is going to do is it's going to create a heat map with those colors. It's going to center it at 0. So exactly in between the two colors is going to be a correlation of 0, which means there's no relationship, or no linear relationship at least, between those two variables. And I'm just making this is just making the font size a little bit bigger. And what this is going to do is translate these numbers into colored squares that match the correlations. So now we've got like dark purple is a correlation of 1. Obviously, each variable, these super dark purple squares down the diagonal. Jamie, do you want to explain why like the correlations are 1 all along this diagonal?
Oh yeah, so if you like look along the diagonal, it's basically saying like the top left one is basically saying rent correlates perfectly with rent, which makes sense because they're like the same like variable. So like whenever you make one of these like heat matrices, like you'll just see the diagonal is just like all perfectly correlated variables because it's just showing the correlation of one variable with itself.
Exactly. Yeah. I think it's like, it's helpful sometimes to look at the picture. Like if we were to just like plot rent against itself,
yeah,
like rent versus rent, which is obviously not something we would want to do in real life, but why not? We get this perfect line, and that's what a correlation of 1 means. Like a perfect line is a correlation of 1, and a correlation of -1 would look like this. Woo! Yeah. Yeah. Okay. That's an aside. So now looking at this, I don't know, it doesn't look like we have very many things that are highly negatively correlated, because we've got like the largest negative correlation that seems to be on here is like -0.3 maybe.
I think
but we could take a look.
Yeah.
We'll take a look.
Yeah. It looks like
Okay. So let's take a look at that one. Floor and building age years. Years and floor. Show. Whoop. What did I do? Did I? Oh, building age years.
Okay.
Okay. So I guess we kind of see what this looks like. Like, it's kind of a mess of points, and you'd almost draw like a straight line through it. But it does seem like on the lower floors, there's a bigger range. Or sorry, are these floors? Now I'm confused again.
I think the y-axis is floors.
X label.
Yeah.
Age. Floor.
Yeah, I feel like this makes sense because it's basically saying the older buildings are less likely to have more floors. Right?
Oops, I meant to say Y label there. So yeah, it's saying the older the building, like the older buildings have in general, like less than 20 floors, except for this one building over here. If the building is 175 years old, there's no way that it has more than a few floors. But if the building is brand new, it seems like there's a much bigger range. There's up to like 80 something floors. So that makes sense. Yeah. So you could imagine that if you were going to draw a line through these points, you probably wouldn't, but if you were going to, it would probably be like a slightly negatively sloped line. Like we kind of go like this. So that gives you a sense of what these colors kind of represent. Cool. Are there any other ones you want to take a look at? Should we take a look at one that has like a correlation of 0 maybe?
Yeah, so that would be like minutes to subway in size square feet, or like floor and minutes to subway.
Yeah, let's try size square feet and minutes to subway maybe. Yeah. And then we'll move on. Size square feet, and what was it? Min to subway. I don't know. You could do this forever. There's also something called like pair plot, I think, in the Seaborn library. That's right. Oh, yeah. So now we see almost, it looks like maybe there's a slight negative correlation, but not really. So yeah, the less of a pattern you can discern in this graph, the less I would say that there's an association between those variables. Yeah, I think we can just try this. I don't think it's going to work, but there's something called pair plot in the Seaborn library.
Oh, right.
That just like, oh, is it going to do it? It might just be going slow. Oh, yeah, here it is. Wow. So this like simultaneously did all of them. So you can kind of see, like quickly visualize all of these. This one seems to be the clearest. Yeah. And then something like floor and rent, maybe a slight negative correlation. Mm-hmm. Yeah, some of these, it looks like there's really nothing going on here. So yeah, super interesting. Okay. I guess we've got 10 minutes to do the last one, which is talking about 2 categorical variables at once. I think we actually can get through this. This is very exciting. Might be the first time ever. Okay, so let's pick, now that we can't really think about rent anymore and we want to pick 2 categorical variables to look at the same time. I think in the final, let's see, in the final code, I did has elevator and has gym to start. So maybe we'll start there, but we can do any other ones that other people are interested in. So the first thing that I like to do in order to look at an association between two categorical variables is I like to look at a either like it's called either a two-way table or a cross tabulation or a contingency table, all words for the exact same thing. All that basically means is basically a grid showing all possible combinations of categories for a categorical variable. And in that grid, you could either have frequencies or proportions. So I'm going to pull the crosstab function from Pandas, and I'm going to look at rentals has elevator and rentals has gym. And print that out, and we can take a look at it. So all this did was on this column, I have yes and no to has an elevator. And then sorry, the rows are no elevator, yes elevator. The columns are no gym, yes gym. And we can kind of look at this and think about what we would expect if there was no association between these variables. What I'm noticing right off the bat is that if we look among, let's say, the apartments that have no elevator, so just in this top row, we'll notice that if the elevator or if the apartment does not have an elevator, it's like pretty likely to not have a gym as well. Like if you look at this, out of the close to 4,000 apartments or 3,800 apartments exactly in this row, 3,748 of them, like a huge proportion of them, don't have a gym. Whereas here, if you look at apartments that do have an elevator, it's a lot more evenly split. Like just under half don't have a gym, just under half do have a gym. And so then that would suggest that there is some relationship here. Again, this is all well and good. We can look at this picture, but maybe we want either a visualization or a summary statistic to help us understand this a little bit better. Let's do a visualization first. So I think the easiest visualization for this is kind of a slightly altered version of a bar plot. So I'm going to, I'll pull over, or we'll use Seaborn count block. Jamie has some thoughts about all the different bar plot functions. Jamie just wrote, if you're interested, Jamie just wrote a new lesson on using bar plots and pie charts. And we spent some time thinking about which functions to use here or on Codecademy. And we both decided that Seaborn is just so much nicer, or just makes things so much easier. So I'm going to make a bar plot with has elevator as the X. So I want to split based on whether or not an apartment has an elevator on the X-axis, which is that horizontal axis. And then on the Y-axis, I want to know actually, it's automatically going to do count on the Y-axis, so I don't actually have to say anything because it's count plot, but it's really a bar plot. And then I'm going to say hue equals has gym. So what that's going to do is it's going to divide each bar into a separate bar depending on whether or not the apartment has a gym. And it's going to, hue is just another word for color, right? So it's going to like color the bar based on whether or not it has a gym. And then my data is rentals and then PLT. And I think this kind of illuminates what we saw in here a little bit more clearly, where we now see among the apartments that do have an elevator, these bars are pretty close to equal, right? But over here, if the apartment doesn't have an elevator, we see this like huge discrepancy. Like if it doesn't have an elevator, it almost certainly Ooh, this is interesting. So it almost certainly does have a gym if it doesn't have an elevator.
So if it
That surprises me.
So if it if it doesn't have an elevator, no, I think it's still saying that it's.
Oh, it almost certainly does not have a gym.
Yeah.
Sorry.
Yeah.
Oh my God. My brain on a Tuesday afternoon, you guys. It has been a long day. Yes. If it doesn't have an elevator, then it almost certainly does not have a gym. So you can kind of visualize these numbers a little bit more clearly. In the next module or the next couple of live streams, I think it's a few live streams away, we're going to talk about hypothesis testing. And we'll talk about some ways of like testing a theory about whether or not two variables are related at a population level. But there's a function from there that I think is also useful in this context. So I'm going to pull that out as well. So it's from SciPy stats again, this chi2 contingency function. And if we create, so here we have this cross tab. I'm gonna save it as something. And then I'm gonna run chi2 contingency on the cross tabulation. One of the things that does, so you'll see there's a bunch of outputs and you can kind of ignore the first three outputs for right now. But I think the last output is interesting, and this is the last thing I'll go over today. But this matrix is is basically like a version of this matrix, except that in this one, it's the expected values that would exist here if there was no relationship between these two variables. So it seems a little confusing. Like you might think that like if there's no relationship between whether or not an apartment has a gym and whether or not an apartment has an elevator, that there would be like a quarter of the observations in each of these boxes. Like at least that was my first intuition when I first learned about contingency tables. And that actually is not true, because you can see if you just ignore the I'm putting my hand over it, but I'm now realizing no one can see that. If you just ignore the whole has elevator thing, you just look at whether or not an apartment has a gym, you'll see, right, that like there are a lot more apartments that don't have a gym than that do have a gym. And that's perfectly reasonable. So like by random chance, we would expect more observations in this first column than we would expect in that second column. And we could give that like the probability, I guess, of whether or not an apartment has a gym as a value, right? And we could also give a probability for whether or not an apartment has an elevator. And then we could use those two probabilities to get values of these numbers if there was no association. And it's not going to be just like 25%, 25%, 25%, 25%. This function does it for you. In our content, we actually go through the process of calculating it for yourself so you can think about it a little bit more deeply. But I think it's useful to take a look at this and be able to compare it to the observation. And of course, like the further away these numbers are from the observed numbers, the stronger the association there. And here we see like in this top right corner, if there was no association, we would expect 546 apartments in the has no elevator and has gym combination, but instead we see only 52. That's pretty far off. So it's suggesting a pretty strong association. Awesome. Okay, we are like right at 5. I feel super good about that. That is very exciting. I'm really glad that all of you joined us today, and I hope that more of you will watch this later on. We'll be back next week starting our discussion of the central limit theorem, and I am like beyond excited for it. This is going to be my favorite live stream maybe of the whole series. Maybe my favorite will be going over the simulation of the binomial test, but like this is my second favorite. And I feel like this is where we're going to get more into programming and more into like conceptual ideas. And it's going to be really, really fun. So it's one of those things that can be tricky and it's going to be like thought provoking. but I really would love to have lots of people there to like ask questions and slow me down and also get excited about it like we are. That is it for today. Definitely join us next week. Post comments, feedback, anything you want to ask as well in the YouTube video comments or even on the Codecademy forums. We'd love to hear from you. See you guys next time.